I'm okay. Let me know how it goes in there.
I don't know. Actually, I've had one shot. Alright. Love you. Good job.
Hello everyone. Let me change the mic settings just a little bit here. We are trying some brand new things in Amour Learning. Some interesting stuff. First off, that intro video, hopefully it worked. Maybe it didn't, but I hope that it did. We have a lot of viewers today. I'm actually really impressed. So we have 5 viewers right now. Which is a lot more than what we normally have. Normally we have like 1 or 2, but so I like the progress. We're making progress. What is this? This is Amour Learning. Basically, the way this works is it's free tutoring every Thursday and Sunday at 9 p.m. Eastern time, which is about 22 minutes ago. But our previous computer is no longer working, and we've had some inconsistencies. So, for example, last Sunday we did not actually run a video, and so for that reason, the reason why we didn't run that video was because the computer was having some issues. So we changed computers to a much faster computer. Now this will be able to sustain this video, which is really exciting. I noticed that there are some delayed frames. If you guys notice that there are any delays in either the mic or the video frame rate, if there's some issues, let me know. But basically, I'm going to answer your guys' math questions, and the way I'm going to do that is I'm basically going to transition to this screen over here where I can basically write down some math here, and you guys can see that math, and we can work together solving math problems for free. Let me adjust this a little bit. There we go. Now, a couple of announcements to make before we get started on the math questions that we already have. First off, I do want to mention that we're trying to push a statistics course right now. We took a delay, but we are going to start adding those videos into YouTube within the next couple of weeks. So the reason we took a delay was due to some other, I teach at a university, so some work with that kind of conflicted with the work that I'm doing with YouTube, so I had to prioritize my work as a university professor. But now that we've gotten over that hump, we can now finally start publishing some of those videos. Our goal is to publish about 3 videos a day, so if you're interested in statistics, that's the course that's going to be released within the next couple months, and then after that we'll start doing another class. Alright, so we do have a, well actually from your guys' view it's over here, we do have some questions in the live chat, but if you have any questions, best way to do that is to post your questions in the live chat over here so that I can address them, and I will answer every single math question that I get asked tonight. So please ask your math questions. If you have math homework or whatever, we'll go over everything in full detail. So I'm pretty excited about this. By the way, if you noticed, the layout is kind of new, and we also have this weird, crazy intro that we added. So this is just new stuff. You're probably going to see this change a little bit over time, but this is something that I threw together in the last like 5 minutes. All right, well, let's get started with the questions that we have. So first off, we have Darts. I hope I might have said that name wrong. Darts has a question regarding differential equations. So his question is, how can we use differential equations in real life? So let me address this first. differential equations is very interesting topic, and I studied it a long time ago. I have not actually taught this course. This is one of the only undergrad courses that I haven't really taught. How is it useful? Well, basically anything that moves, you're going to need differential equations. So if I could give you the best applications, I would say the medical field and yeah, just the medical field. Basically the medical field and aerodynamics and engineering frequently use differential equations. How? So let me give you some examples of how. Let me pull up a chart here so that you guys can see. Alright, so let's talk about how differential equations is actually useful. Let me move this a little bit so we can, there we go. It's back. Alright, so this is how it's useful. Basically, by the way, my screen's over here, so I'm going to be looking this way. It's not that I'm like looking a little bit off. I actually do have a TV over here that's allowing me to see all my work. Okay, so let's see if this works. Yep, good. Let's talk about how differential equations is useful. So first off, what is differential equations? Basically, the goal of differential equations is to understand a system where you can't quite see how the output and the input interact with each other because you have other things involved. So let me give you an example. If you have something like y equals 3x plus 1, let me make my ink a little bit thicker, and maybe I can make it monotone. No, I can't. So y equals 3x plus 1. With this equation, I understand everything that's going on with the input and the output. So as the input increases, the output is always going to change. It's always going to increase 3 times as much as the increase in the input. So for example, if x goes from, let's say, 1 to 3, that is a change. The change of x is 2. And the definition of slope, this thing right here, this 3, basically what it means is the change in the output is going to be 3 times as larger as the change in the input here. So I'm going to know that my change in my output is going to be 6. Now, I don't necessarily know what y is, but I know that if I plug in x equals 1 into this, I get an output of, what is that, 4? So my output is 4, and I know how it changes. I know that the output increases by 6 units, so this output would be 10. So I know how the inputs and the outputs change because the formula is relatively clear. And this could generalize to a lot of different things. So for example, if I have something like y equals 3x cubed plus x squared plus 2x minus 1. Something crazy like that. Now it's a little bit harder to understand how y and x change. And the purpose of calculus, which I'm assuming if you're in differential equations, you're going to know a little bit of calculus. The purpose of calculus is to understand how x and y change based off of what's called the derivative. The derivative represents instantaneous rate of change. So basically slope, but at an instant. And we could go over for like 30 minutes talking about whatever that means. But I'm going to assume that you have some sort of understanding of what that is. But the idea is we can understand how x and y change together. So if I give you an x, you can give me a y. If I give you a y, you can probably use Wolfram Alpha or Siri or some other calculator to figure out what x is. So even with these dynamic equations, or I should say formulas, we can understand how x and y change together. Now, differential equations is a little bit more useful and more difficult to understand. And I'm going to explain that in a second, but I'm actually going to jump over to the live chat. I want to see if anyone has any updated questions, or if you have an updated question for me, and then we'll continue with this problem of the purpose of differential equations. So it looks like we have no new questions. But again, if you guys are joining in on Amour Learning, we do free tutoring every Thursday and Sunday at 9 p.m. Eastern Time. Make sure you subscribe. It's here. Let me point it out to you guys real quick. You can subscribe. I think it's down here. If you guys subscribe down here, you'll be able to get notifications. Ring that bell, and you'll be able to get notifications of when these YouTube live events occur, so that you can join us and not have to like put it in your calendar or something like that. Okay, so looks like we have no new questions. But again, if you guys have any questions, post your questions in the live chat. That's how I see whether or not we have any new questions. But let me go back over to our question about differential equations. So now, what are differential equations? Differential equations are, I don't really like the name equations because technically they're formulas. I believe there's a difference between the two, but I'll grant the word equations. Differential equations is basically when you have equations that you can't really understand how x and y change, even though it involves x and y within the equation. So formulas these equations are supposed to give you an understanding of how x and y change with each other. But if I tell you, for example, y prime equals 3, what does that mean? Well, this doesn't really tell me a lot of information about x and y. For example, what this basically says is that the change in the output is 3. Meaning that the change, by the way, y prime is, by definition, delta y over delta x. And so if delta y over delta x equals 3, that means that the change in y is always going to be 3 times as large as the change in x. Another way of thinking about this is delta y equals 3 times delta x. So that's actually how I think about it the most. I'm not very, well, I am familiar with that, but a lot of my students struggle with division. So I just move the delta x over, and this is how I think about it. The change in y is always 3 times as large as the change in x. Basically, the slope is 3. That's what this means. But with this information about y prime, I just give you that y prime equals 3. What does that tell me about y and x? Well, unfortunately, not a lot of information, because I know that the slope is 3, but for example, what is the output when the input is 0? What do I get when I plug in 0 into this equation, into x? And I can't tell you that information, so I need some information about x and y. For example, I know that if I plug in 0, I get 4. So this would tell me then that using slope-intercept form, y equals 3x plus 4. But, oops, let me undo that. But this right here, to me, is so much easier to look at than the combination of these two things. And so the point of differential equations is, how do we take something that is intricate and put it into a way that is easier to understand how x and y are coordinated together? How do they change together? And that's kind of the name of the game with differential equations. So obviously, y prime equals 3 is really easy, but what happens if I start saying like y prime plus 3y equals 5? If I say something like this? Well, we run into a problem. We run into a huge problem. In particular, I can't really tell you how x and y change. So for example, what's the slope? Well, that depends on what the output is, right? For example, if y equals 10, I can tell you that the slope is, let's see here, 10 times 3 equals 30. 5 minus 30 is negative 25. So this really doesn't tell me a lot of information about what's going on. But I can draw you, for example, a slope field to explain what might be going on. And that is slope fields or vector fields, or there's a lot of different terms for these things, but they're extremely applicable. Aerodynamics, for example, when you draw airplanes, or not when you draw airplanes, when you build airplanes, you got to understand how wind affects the wing of the plane so that can lift it. And you need to understand how the forces are affecting on it. And you can consider air resistance as a vector space, or as a vector field, or a slope field. And because you have a bunch of forces applying to a wing at any given time. So that's one application of these things. But yeah, what's the purpose of DiffEq? Basically just to understand what's going on with X and Y when there are multiple things involved, including the slope. And maybe in some cases we might have some crazy stuff like y double prime. Oops, hold on, let me add this. Y double prime plus 3y prime. You know, what do we do in those scenarios? It's a good question. It's kind of a tough answer to give. Now, I do want to mention, I don't know if you asked me whether or not if you wanted me to solve these problems, but let me go back to the live chat, see if we have any more questions, and then we'll come back to this question, because this is a really good question. All right. It looks like we have no new questions. That's perfectly okay. But again, by the way, what you're looking at right now is what I see on my screen. So this is kind of what I would have to work with. But according to my screen, we have no new questions. If you guys have any math questions, please post your questions on the live chat, and then I'll be able to respond to those. So let's see what the question is. How can we use differential equations in real life? I believe I answered that question. Basically, vector fields, slope fields. Please solve. Yeah, how do we solve that that first order linear equation? Good question. I'll get to that in a second. So let's talk about how to solve a first order one, and then what is the difference in solving a second order versus a first order. And when should we use partial differential equations? So let me get to the solution of a first order equation. So real quickly, I'm actually going to use a little cheat sheet because, and then I'll explain, I'll prove I'll give you what's called a heuristic. Heuristic is basically a way of solving these problems that makes sense. I'm not going to solve this one. I'm going to solve a little bit easier one, something like y prime and just 3y equals 5. And then we'll go over a solution. Give me 1 second. I'll be right back. I'm going to grab my book and use it as a cheat sheet. You've probably heard this one before, but I haven't taken this class in probably about, gosh, I was 18 years old, so 6 years. But I remember I need to multiply everything by e to the x. Yeah. You know what? I don't need a cheat sheet. Hold on. Let me try this. I believe, so if I multiply everything by e to the x, there's a reason I'm going to do that. So I'm going to multiply every single term here by e to the x. So this would be, okay, hold on. There we go. So this would be y prime e to the x plus 3y e to the x equals 5. Okay. It's not e to the x I want to multiply. Oh, 5 e to the x. Sorry. But it's actually not e to the x that I want to multiply by. It's actually e to the 3x. And I want to explain why, where I get this 3 from in a moment here. But if I do that, hopefully what you can notice is that this right here is the result of the product rule. So when you took I'm assuming you took calculus. That is a prerequisite for differential equations. But the idea is this is actually the result of a product rule. I'm actually going to rewrite this. Let me rewrite it below. So this is y prime e to the 3x plus, and I'm going to actually write it like this, y times 3e to the 3x equals 5e to the 3x. Okay, so what the heck am I doing? Why am I doing it? And what's going on? So, real quick, I want you to notice that there are two functions in play here. I'm claiming that this is actually the result of a product rule. And that's actually going to be important. This will allow me to solve the problem. So let me show you what I mean. First off, I'm going to remind you what the product rule states. Basically, the product rule states this. If f of x equals g of x times h of x, which basically means if I have two functions that are being multiplied by each other, I can't just take the derivative of each one. That's not legitimate. If this operation right here was addition, then we could actually use we could just take the derivative of each one independently. But in this case, we can't because it's multiplication. We have to use what's called the product rule. And again, I'm not going to sit here and explain to you what the proof of the product rule because that is a Calc 1 thing, and we can spend another 30 minutes talking about that. But, you know, come back Sunday. What is the derivative of this? F prime of x equals g prime of x times h of x plus g of x times h prime of x. So that is the product rule. Now, I'm claiming that this thing at the bottom, right here, is the result of a product rule. It's like the remnants of a product rule. Basically, what I'm saying is, it looks like someone took the product rule and that was their answer. Now, it's kind of hard to see it, but let me draw it in this way. If I circle things in a certain way, maybe you'll be able to see it. But let's change colors here. This is going to be my G prime and G. That's G prime and G. So that's this part and the product rule. And then the other component is this part and this part. So this is my H and this is my H prime. So notice basically we have G prime, which is Y prime, and G, which is Y. That's actually true. The derivative of Y is Y prime. So that's consistent. And then here we have e to the 3x, and the derivative of e to the 3x is 3 times e to the 3x, which is my H prime here. So this looks like the remnants of a product rule. Basically, the product rule already happened, but what were my original functions? What was G and H? What is f of x here? That's what I'm trying to figure out, and that's actually going to help us solve this problem. It looks like my original function was y times e to the 3x. Now I want to mention something here. I used y in there. Typically in calculus 1 to be specific, you just have x's. There's no y's. So, but there was one concept in calculus 1 called implicit differentiation, which allows you to take derivatives of like things like y and y squared, which involves the chain rule. Again, a conversation we can have another day, or if you have a follow-up question and you want to ask about that, we can talk about that as well. But let me explain what's going on here. Basically, this left-hand side of the equation, let me erase some stuff first before I start pointing to things. There we go. While I'm setting this up, if you guys just joined in, please feel free to post your math questions in the live chat, and I will answer every single one. Right now, we're talking about differential equations, and we're talking about how to solve. In this case, I believe, correct me if I'm wrong, this is first-order ODEs, simple ODEs, or whatever. They have like these long names that are ridiculous, but I believe this is first order. That's all I know. So basically, my original, what I did on this left-hand side, this part right here, this looks like the derivative of y times e to the 3x. So I'm going to write it like this. So that prime means just take the derivative of that. If I take the derivative of that, then I should get y prime times e to the 3x plus y times 3 times e to the 3x, which is exactly this thing right here. So I just rewrote the left-hand side as this guy right here. I just wrote that, I just rewrote it in a different way. And there's a reason why I'm doing that. this equals 5e to the 3x. So this will allow me to solve the problem a lot easier, and I want to show you how. And then, by the way, there's still a lingering question, how did I get e to the 3x? Why did I multiply everything by e to the 3x? We'll talk about that in a second. That was actually a cleverly designed function that we multiplied everything by. That was not by accident. That was intentional. That was on purpose to make things look like we did a product rule, and then some other stuff. All right, so let me finish this problem. What I'm going to do is I'm going to take the antiderivative of both sides. Now, why would I do that? The reason is because if I take the antiderivative here, number one, I'm not taking the... number one, I would get rid of that derivative on the left-hand side. Because if you take the antiderivative of a derivative, it kind of cancels out. It's like the inverse operation, if you will. And on the right-hand side, if I take the antiderivative of that, well, actually, you can do that with calculus 1. Or maybe calc 2 or what. I think that's calc 1. So, I'm going to take the antiderivative of this derivative. So I'm going to literally shove an integral symbol there and an integral symbol there. But if I want to be precise, I need to put dx on both sides. So I'm going to squeeze a dx on both sides. The reason why I need to squeeze a dx on both sides is in certain differential equations, in certain diff-EQ problems, some things cancel out and some funky stuff happens. So don't worry about that for now. Just note that the antiderivative of the derivative is just the same thing. So these two, in a way, cancel out. And I just get y e to the 3x equals, and what's the antiderivative of 5e to the 3x? Well, I believe it's 5e to the 3x over 3 because it's an antiderivative, and then plus c. And now I can divide both sides by e to the 3x. So I'm going to divide every single term by e to the 3x, and I have y equals 5 over 3 plus c over e to the 3x. And I believe that would be our answer. I want to double check this because I'm wondering if I need to add an extra term. I don't. Good. So this is good. So this is my solution. And then typically they would give you like a point, because at this point we have 3 letters. One of them is a constant that we're trying to solve for, and the only way to solve, which is c, by the way. Your angle, I don't know which angle it is. But to solve for c, generally they give you a point. Like, for example, if I plug in 0, I should get 0, which would make c like negative 5/3 or something like that. So typically they'll allow you to solve for c. That part of the problem is technically Calc 2, Calc 1 stuff. So again, we're not going to get into that curriculum. But this allows me to solve this problem. Now, it was a lot, right? Where did I get what e to 3x from? Where did I get that from? I really want to answer that question because I don't want to... Maybe you know how to solve this problem, but that's because I gave you the first step, just free, and it's kind of random. So let me talk about this problem again. So this is equals 5. I believe the problem was y prime, oops, y prime plus 3y equals 5. I believe that was it right there. Yeah, that looks familiar. So we multiplied, the first step we did was we multiplied everything times e to the 3x. It's a very random thing. The idea is, the way this is written right now, let me use a different color real quick. The way this is written, oh, that's the same color, whatever. The way that's written, it's not the result of a product rule. It does not look like the result of a product rule. So I can't simplify that into one derivative and then just cancel out that derivative with an antiderivative. I can't do that the way it's written. If I take the antiderivative right now of both sides, I'd be taking the antiderivative of y. And I don't know the antiderivative of y if you want to think about, like, we have y's, you have y primes, you have y double primes. If we take the antiderivative of y, we would have like a y negative prime, and I don't know what that is. So we can't quite do that. So the goal is to get rid of all these primes, and the only way to do that is to make this left side of the equation, well, in this case it's over here, I guess. We need to make this left side of the equation, let me make sure I have the screen on. Hold on one second. Yes, I have the screen on. Good, good. I have a feeling, sometimes I don't have the screen that you're looking at open. I have just the webcam open, and then I just start talking to myself, basically, which is bad. That's not the case here. So the way it's written right now is we don't have the result of a product rule, and so we can't get rid of this prime somehow. So we need to multiply everything by something to make this look like the result of a product rule. And again, why is it not the result of a product rule? I do want to emphasize that because that'll help you understand why we need to multiply by e to the 3x. The idea is, if this is my g prime and this is my g, then this would have to be my h prime, and over here I would need an h, and the antiderivative of 3 would be a 3x. So if that was yes, if this was the setup, then we'd be perfectly fine, because we would have the result of a product rule. But that's not what the problem is. The problem is this, and that is not the result of a product rule. So there is a solution. We're going to take this, whatever is the coefficient of y, and by coefficient I mean everything attached to this y here, and we're going to call this function f. We'll just call it f. So that's my f of x. The thing we need to multiply everything by is e to the antiderivative of f of x dx. That works. And let me make sure everything's good. Yeah, this will work. Yes. So that will, if you multiply everything by this term right here, we have to figure out what that is. Then we should be good. Now in this case, we have a 3, so we're trying to find, we're going to multiply everything by e to the antiderivative of 3 dx. And what's the antiderivative of e to the 3x? That's e to the 3 dx. And e to the antiderivative of 3, well, that is just e to the 3x. There we go. And that's how I got the e to the 3x. And if we multiply everything by that, it turns out that no matter what, this will be the result of the product rule. It's pretty cool. I can show that proof, but I'm not gonna, because, again, another 30 minutes. And I'm pretty sure you're more interested in the how-to, because differential equations typically test you on the how-to, not necessarily the understanding. It's just a giant step-by-step process, bunch of step-by-step processes that you need to understand. So that is how we solve single-order differential equations. I'm assuming that the next question is, how do you solve second-order differential equations? And I believe the answer is pretty much the same. There are some subtle differences, but basically, well, actually, no, that's not true. I remember there was a very, very different way of solving second-order differential equations. And it was very intricate. And it involved something like Bernoulli. It's like the Bernoulli process or something like that. It's been a long time solving second-order diffie-qs. I don't remember the process for that one, but this one to me is kind of conceptual, because we're trying to make that left-hand side the result of a product rule, so that we can compactify it and then take the antiderivative of the derivative to get rid of that derivative symbol. And then we get an understanding of how y and x are coordinated together. So yeah, basically the whole idea of differential equations is y primes and y double primes suck. That's the theme. That's the theme of diffie-q. Y prime and y double primes suck. So we need to get rid of them. We have to get rid of them so we can understand how x and y change together. And that's the name of the game. That's diffie-q right there. That's all of DiffEq. Later on, you actually get into linear algebra within DiffEq at the end of this class. So I'm assuming you're mid-semester. Meaning, like, I think you're probably, what is it? It's late. It's the end of September, so I believe we're in like week 7 or week 8. So you're probably just getting into second order DiffEqs. Within the next 3 or 4 weeks, you're going to start getting into like 5 order differential equations. In which case you're going to have. Oh, I remember. Yeah, there was like a y prime and a y double prime, and they'd have to give 2 of those in order to understand how. You can solve for y and x. Yeah, so it's all like coming back to me. It's like, it's been a while. So I was about to say it's like trauma, where you try to erase it all and then pretend like it's not there. But then again, it's math, and I don't hide. Math is not trauma to me. Maybe it is. I don't know. What do you guys think? Is math trauma? I don't know. Let me get to the other questions that you had and see if we can move on. So can you explain how DiffEq merges with linear algebra? Yes. Let me ask you a question real quick. A follow-up question on that. Can you tell me how much linear algebra you know? When we say linear algebra, here, let me move to a different screen so you're not staring at my my tech stuff. How much do you know about linear algebra? I'll wait. There's a little bit of a delay in response, so if you type in anything, it's going to take like probably about a minute for me to actually see it. How much do you know? Have you taken linear algebra? Do you... yeah, that's kind of my question. Have you ever taken linear algebra? How much do you know about it? Do you know, like, reduced row echelon form? Do you know about... Gosh, what other stuff was there? Eigenvectors, eigenvalues, a decent amount. Okay, that's good enough for me to know. So let me tell you how they relate to each other. So let me, real quick. Boy, this is where things get crazy. You just asked a ridiculous question, which is really good. Like, by ridiculous, I mean we just entered into a universe that's just absolutely insane. Apparently, it's useful. So I'm told. So yeah, understanding this stuff will start landing you some jobs that are like at least 70K, pretty easily. So let's talk about this. Let's say we have something like, let me make sure I get this correct. I need a very careful understanding of what to do here. Let's do that same problem so that I don't mess this up, like royally. Let's do y prime plus 3y equals 5 again. Now, how do we use linear algebra? Well, good question. Let me peek. I'm gonna cheat. I think you can only use linear algebra. I think here it'd be kind of trivial linear algebra, so I want more interesting stuff. I think the answer to your question involves second order and third order DiffEqs. But let me double check that. I have here, I believe this is where it is. This is like such an old book. Higher order linear equations. Yikes. And well, I just want to show you guys. I don't know if you can see that, but this is just words. So apparently DiffEq is applicable. That's I've never touched the applications of DiffEq, but yeah, these people can get a little insane. There we go. I think we're getting there. Where are my matrices? I don't want Laplace transform. Oh, Laplace transforms. Don't even get me started on those. Let me might start, here we go. Here we go. I found it. I found my cheat sheet. Okay. I'm not interested in linear algebra. I'm going to assume you already know linear algebra and Diffie-Q. Okay. Yes, here we go. So this is how I'd write this. Basically, let me double check this. My goodness, these books are absolutely the most insane things to try to understand. So you can feel me here for a second. Books on Diffie-Q are bad. They're bad. They're really bad. I'd love to write one of these things. Honestly, I just need to teach a course on this. Because this is nuts. Let's try to find... I just want to know what X represents, and then we'll be done with it. Give me here we go. Here we go. Here we go. Here we go. So that's how it works. What if X is like a variable, but instead of X, we're going to use T. Typically, so instead of X, we're going to use T. T is going to be our input variable. This is how I think about it. T is our input variable. Oh, by the way, if you're just joining in, make sure it's kind of hard to see. It's way over there across the across this white blank screen. There's a live chat. You can ask any of your math questions over there, and I'll answer them all. So let's talk about this. So what is how does linear algebra and Diffie-Q overlap? This is a really important question because when you take graduate level Diffie-Q, which I took like half of it, and then I literally got an A in it, I think. Yeah, that was only like a couple years ago. That's when I took graduate level. But graduate level Diffie-Q is basically linear algebra plus Diffie-Q. That's all it is. So so this is, I'm going to give you guys the intro theory of understanding this. And I have to be very accurate. I want to use notation that you're familiar with because typically students who are in Diffie-Q undergraduate level, they use Y's and Y prime and Y double prime. But in graduate level Diffie-Q, they use x1, x2, and the reason for that is because if you've taken linear algebra, you've probably seen stuff like this. X1 plus 3x2 equals 5, and something like x1 minus 2x2 equals 2. So what is x1 and x2? So this is the sort of thing that you would typically see in a linear algebra class, x1 and x2. I'm going to use y1 and y2 to signify that these are different variables for the outputs. So the input is t, and I'll actually write that up here. The input for linear algebra, the overlap between linear algebra and Diffie-Q, the input's always going to be t. And the reason why it's t is because the applications of this are almost always typically things that involve time as an input. And time is going to change a lot of outputs simultaneously. So time is going to affect, for example, the stock market prices. But it's also going to affect, for example, let's say water levels of the ocean, the sea levels rising or something. T is also going to affect temperature. It's going to affect a lot of different things. So let's assume for now that t is affecting a lot of different outputs. And these outputs are going to be signified with y's. So I'm going to say y1, for example, y2, y3, y4. But again, you have to understand that linear algebrists, people who study linear algebra use x1, x2, x3, x4, but it's kind of annoying because people consider x to be an input. But in this case, the input is t, not x. So I'm going to use y1, y2. That helps me understand it a little better. So let's understand what's going on here. What if we had something like y double prime. Let's do y1 double prime equals y1 prime plus 3t. And then, let me make sure I get that right. Oh, let's do 3t times y. Actually, let's just do 3y, because I want to keep everything basically systems of equations. 3y plus 3t. Let's do something like that. And then this is y1, by the way. These are all y1s. This is my y2. y2 double prime equals, let's say, y2 prime plus 2y2 plus 4t. And then we might have y3 double prime equals y3 prime plus 10y3 minus 7t. So a good question is how does linear algebra relate to this? So if you look at this, this actually looks a lot like a linear algebra system, and it is. And it's really cool how this works. But the idea is I'm going to say that y is going to be a vector. Y is going to be specifically the vector y1, y2, y3. And if that's the case, then this entire thing is literally just y double prime equals y prime plus 3y plus 3t. And now we can solve this. This right here is just a second order linear equation. And I forgot how to solve those, but we can easily solve that. And the idea is, instead of y being a function, or y being the output of t, it's actually a series of outputs when you plug in t. So for example, this right here is what y is, actually. That's a good way of thinking about it. And so, well, actually, we have sort of a problem here. Let me clarify it. This is not completely correct. Actually, this is definitely not correct. So let me back up a little bit here. Let me rewrite this in a different way. I messed up already. But that is y. Y is just y1, y2, y3. Here's how I would think about it. This is 1, 1, 1. These are supposed to be all y1s. Everything, right? Jeez, I don't know. See, this is why you shouldn't have me as this is the one question I thought I could get right, and I didn't. I'm surprised, because this is my grad Diffie class. But like, the idea is, I don't know, maybe you can see the linear algebra in this, and linear algebra helps you solve this, and you might need to be doing some reduced row echelon form stuff and other linear algebra stuff. But yeah, I believe these all need to be y1s or something like that, and you would consider this a little different and this a little different. But yeah, it's these things do overlap somehow. Sorry, that was like the worst answer I probably could have given, so I apologize about that. Let's see. I took a course for a few years ago. Yeah, that was the best answer I could give. Let's see. We have another question from Pedro. Pedro asked a really good question last week, by the way, guys. I forgot what it was on. It was about cones, I think. That was a great question. I'll get to your question in a second, Pedro, but let me talk to Darsh. I don't see your name, sorry. And let me address the question regarding partial differential equations, if you don't mind me. And I apologize for not having a good answer to how they relate. They relate because this says so. That's my answer. Weak answer. Weak answer. Sad. All right. Partial diffeq. What is the purpose of partial differential equations? Well, the purpose of partial diffeq, or partial differential equations, is to understand how three-dimensional surfaces or three-dimensional functions change, like how different outputs change together. So let me explain what I mean by that. All right, we're back. Sorry. Let me pull up this here. So I'm going to attempt to draw a three-dimensional graph here. This is where things get kind of easy because already off to a bad start. Here, let's try that again. Ooh, I feel like this is not bad. So here I have a three-dimensional coordinate plane, and the idea is we have this XY plane, and then Z is my elevation, if you will. So the idea is we have a surface on here. So a function in Z, typically we'll use we won't use this. We'll use function notation, which is something like f of x and y. So it's a function where x and y are both variable inputs. So I might have something like f of xy equals x squared plus y squared, for example. And I believe this is like a paraboloid or something like that. Right? Yeah, I think that's right. But anyways, so the question is, how do these? What is slope? What is slope? Well, that's a really good question because what we need to go on. We need to talk about the basic understandings of slope. So when I say slope equals 3, what does that even mean? Typically, when we ask, there's research that actually shows this, and you can look up 2 authors: Pat Thompson, Marilyn Carlson, Cameron Barley. What's his name? Chop that up so bad. Gosh, there's so many people. Kevin Moore. A lot of people out there that study this sort of thing, I think. At least my impression is this is what they study. Slope equals 3. What does that mean? Well, let's talk about what that means. Basically, the idea is slope, we were always taught that it's rise over run. Slope is rise over run, but I'm going to write it like this. Delta y over delta x equals 3. And better yet, I'm going to write it like this. Delta y equals 3 times delta x. Basically, the idea is this tells me how the change in the input affects the change in the output. So the idea is that we have 2 variables, x and y, and they're both changing simultaneously, but they change together in a certain way, according to maybe like a linear relationship. The idea is the change in the output is always going to be 3 times as large as the change in the input. And so 3 is like, I'm not going to go too far into it. The idea is change in the output is always 3 times as large as the change in input. But when we have 3 variables, what does slope mean in that case? Well, the idea is we have this output, which you can call, by the way, most people do, you can call it z. The question is, how does z change? Well, that's a really interesting question because it really depends on what input you're changing. Now we have 2 inputs. We can change x and we can change y. So the idea is z will change depending on which input that you change. And it's really hard to talk about how z changes if you change both x and y simultaneously because those are both my input variables. And so for that reason, we talk about what are called partial differential diffeqs, which talk about how z changes when you change x in a certain location. And so it's really, so the idea is slope really only allows you to understand how two variables change together. And the purpose of partial differential equations is to pick two variables and see how they change together at a certain point. So that's partial differential equations. So for example, if we're looking at the point in this graph, let's do 1, 1, 2. That is a point on this graph. If you plug in 1 into x and 1 into y, you get x squared plus y squared, which is 2. And I want to know, how does z change? Well, it depends. Do you, let's look at this graph here. Here's x equals 1. Here's y equals 1, let's say. So we need to go, this is my input, and my output is represented by a vertical distance of 1. So that right there is the point 1, 1, 2. I know it's a little hard to see, so I apologize, guys, but let me give you a visual of what's going on here. The idea is that's my output, and as I change y, so that's my change in y right there, or I change x. Let me use a different one for that, different color for the change in x. Maybe I change x. The idea is, how does z change? Does it go up? Does it go down? And that's what partial diffeq finds. So the difference between diffeq and partial differential equations is diffeq, the question is, how can we understand how two things change together when differential or actual derivatives are in the way, like y prime and y double prime? How can we understand how y and x change together when there are these y's and or y primes and y double primes in the way? And then partial diffeq says, how does the output of a multivariable function change when we change individual input variables? So, for example, in this scenario, if we talk about, let's see here, fx, which is 2x, and fy, which is 2y. Maybe I'll change this a little bit. I'll change it to y cubed. That way we can make this a little bit more interesting. So in this scenario, I should be writing not 2y, but 3y squared. So if we change x by 1, that means that, well, let me talk about what's going on. First off, we can understand the slope. There's actually two of them, if you will, at this point right here. So f of x at this point is going to be, let's see, if we plug in x equals 1 into that x, we get 2. And then fy is, when we plug in y equals 1 into there, we get, let's see, that's 3. Yeah, that's good. So the idea is, if we increase x by 1 unit, or my output is, or if whatever my change in x is, my change in z, my change in the output is probably going to be twice as large as the change in the input of x. So if I change my x by 3, then my output should change by 6. If I change my input by -1, then my output should decrease by 2. So the idea is, this is saying that the slope is 2 according to the x direction. And then this is saying how my output changes according to the changes in y. So if the change in y is 1, then my change in z is going to be 3 times that change in y, which is 3. So the idea is, if we consider this point right here, and I'm going to have to erase a couple things here. If we consider this point 1, 1, 2, and we go to the point, we increase, let me change the color here. If we increase y by, or let's increase x by 1. So if we increase x by 1, what happens to the output? Well, according to this, my output is always going to change by about twice as much. So that means my output should increase by about 2. So my output should be 4. But it's not, because, again, we're talking these partial diffie-q's correspond to instantaneous slopes. So you have to understand that this is probably going to be wrong. If I plug in 2 here, I get 4 plus 1, which is 5. Ah, darn, we got it wrong. But why did we get it wrong? It's because we're not talking about instantaneous rate of change. But that's kind of the gist of how partial differential equations works and what it is. All right, Pedro, let's get to your question. I hope I answered your question. Darsh, I think I answered every aspect of it. But let's get to Pedro. So Pedro, this is a great question. Can you explain why, if we throw a dart on a number line, the probability of getting a rational number is 0? In another way, why the rational numbers doesn't exist in the number line. So there's a subtle misconception here. That's okay. Rational numbers do exist on the number line. They're everywhere. In between every 2 rational numbers is another rational number. So like 1/2 and 1/3. Take the average of those two. The average is always going to be rational, and it's going to be in between those. So you have a really interesting question though. Why am I going to immediately get an irrational number? And the answer to this is actually non-trivial, but let me answer it in this way. Basically, let's talk about just the numbers between 0 and 1, and then everything else applies with the rest of the number line. So here's 0, and here's 1. And I'm going to take a dart, and I'm going to throw it at this number line. And I'm going to show you that it's definitely not going to be a rational number. 100% not a rational number. And I'm going to explain why that is. Now, this number that I hit, it's going to definitely have a first digit of 0. The chance of me getting 1 is 0. And I hope we can understand that the chance of me hitting exactly this location right there is 0. So my first digit is going to be a 0. I guarantee it. Now my second digit is going to be 0, 1, 2, 3, 4, 5, 6, 7, 8, or a 9. It's got to be one of those numbers. So it's going to be one of those numbers, and it's going to be pretty random because I'm throwing randomly. So we're gonna say that it is, we'll call it A1. So that's my first digit. My next digit is A2. My next digit is A3. My next digit is A4, and so on. So those are all my digits: A1, A2, A3, A4. And the idea is that these numbers are pretty random. All of them. A1 is going to be a random number. A2 is going to be a random number. A3 is going to be a random number. By random, I mean it's going to be either 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. But I can't tell you with any sort of certainty which of those 10 numbers, the 10 digits it's going to be. So for that reason, these are just, I'm basically getting when I throw a dart at that number line, I'm basically throwing a dart at 10 digits for each of these. And I'm picking, so I'm basically throwing a bunch of darts. So for the first digit, first decimal number, it's going to be a 0, 1, 2, 3, 4, 5, all the way up to 9. One of those numbers. And I don't know which one it is. It's a uniform random distribution, if you will. Now, that's going to be the case for every single digit. Now, what is a rational number? Well, in terms of decimal numbers, this is kind of hard to prove. Every rational number has repeating digits. So basically what this question is asking is, what is the probability that this infinite string of digits is going to be repeated over and over and over again? And the answer is 0. And this actually has to do with the law of big numbers. It's kind of weird, but the idea is that if you have a random process like this, the probability that and it's an infinite process, the probability that the entire thing is going to be uniform is 0. To give you one example, I have a coin. Hey, look at this convenient coin right here. No, it's a pick. It's a guitar pick. Darn. Darn. No, I lost my nickel. Oh, I had a nickel today. I was teaching probability in my math concepts class today. That's all right. So yeah, if you flip a coin, you flip a coin infinite number of times. What's the probability that you're going to get heads every single time? The answer is 0. The reason why it's 0 is because eventually, according to the law of big numbers, if the probability is actually truly 50-50, eventually about half of your flips are going to be heads and half of your flips are going to be tails. So to see literally an infinite string of heads is impossible because of the law of big numbers. And for the same reason, to get repeated digits over and over and over again, a string of repeated digits, which is a rational number, it's not going to happen. It's not going to happen. Eventually, there should be some sort of chaos somewhere down the line of these digits and these decimal numbers. So for that reason, the probability of getting a rational number between 0 and 1 is 0%. And then the same concept applies when you extend this number line and we look at the entire number line. It's the exact same concept. So the probability of me getting repeated digits that's nice and convenient, basically 0. I hope that answers your question. Let me see if there's any follow-up questions, maybe. Oh, we have a comment. Let's see. Wob2, I might have just totally chopped your name. I mean, it's hard to see from this angle. Hold on. Wob2 says, "Thank you for this, Professor. I was just watching for the first time. Hey, and I'll try and prepare 2 questions I've wondered about for another time." Yeah, ask your questions, please. This is a free tutoring session for everyone, and consider subscribing too, because you'll get notifications of when we do these events. So Pedro says, "Thanks, no problem, man." I hope that helps. I hope that makes sense. I kind of use like a bunch of different theories, like the law of big numbers and decimal numbers. It feels like I'm proving that there are infinitely many irrational numbers using the whole A1, A2, A3 thing. If you've seen that before, what is it called? The where you shift all the digits by 1. Oh, what is it? Oh, I forgot the name of that proof, but whatever. I used a lot. I was kind of involved. Can you discuss? This is Darsh, you asked a really hard question. Can you discuss stochastic differential equations? No. So my short answer is no. So to give you kind of an idea of where I'm at, where I was in grad school, I studied in the pure math department, specifically regarding number theory, algebra, and graph theory. And I was interested in linear algebra, and graph theory, and how they mix together. So cool. That stuff was awesome. So first off, by the way, let me just take a little side turn. You can ask whatever follow-up questions you want over here. And by the way, guys, we have 4 viewers right now, which is still pretty good. Hey, it's 4 people that need help, I guess. And by the way, if you're not wondering what this is free math tutoring. Make sure you ask your questions in the live chat. All right, here's a follow-up question. I know one part is deterministic and the second part is random. Ooh. I feel like I've been triggered. So I'm not a statistics guy. You should probably know that. I just absolutely hate statistics. I teach it. It's actually the first course that I'm releasing on this Amour learning channel. You're gonna see it pretty soon here. But basically, yeah, I'm not a statistics guy. I'm a graph theory. But I just want to quickly talk about graph theory and linear algebra. So if you think it's weird for linear algebra and linear algebra and diffie-q to mix together, like those are 2 totally different. Like an advanced calculus and an advanced algebra and hybrid the 2. Graph theory and linear algebra, those two things mixing together is the most insane thing I've ever seen, and it's so cool. I love it. It's so cool. It's like, it's the perfect mix of algebra and graph theory. That was my thing. I love that stuff. Alright, does anyone have any follow-up questions? Well, too, if you feel free, you can ask whatever questions you want. Or if you're, maybe you already left, you can ask your questions in the comment section, and then I'll address those. I don't think we have any follow-up questions, but I'll give it some time. So maybe I'll do a brief, segue into graph theory. So let me, you don't know what graph theory is, today's going to be your lucky day. Graph theory is the most amazing math topic ever, and that's not even subjective, it's like objective. No, I'm just kidding. People like statistics, I guess, too. But graph theory is pretty cool. Let me tell you what graph theory is. If you think it's if you think it has anything to do with graphs like this thing, you're wrong. This is definitely not a graph when I talk about graph theory. In the context of graph theory is the study. This is amazing. Hold on, sorry. I have to talk about this. Graph theory is a study about dots and lines. So if you have a bunch of dots and there's some lines connecting the two, or lines connecting these dots, like that maybe, like how do you understand these systems? Now this thing that you're looking at is widely applicable, consider Facebook. Facebook is a giant network, but by network I mean a graph. So this is like, for example, Kyle, and this is I need a name, John, and this is Daniel, and this is I think of names off the top of my head, Matt, and Jared. Bunch of names, and this is like a network that talks about how these people are connected. So Kyle is friends with Daniel, John, and Jared. John is friends with Kyle and Daniel. Daniel is friends with Kyle, John, and Matt. Matt is just friends with Daniel. Jared's friends with Kyle. Wow, there's a lot of stuff going on here. This graph packs a lot of information. But there are some really cool things. Like, for example, if everyone has at least 2 friends, sorry, if there are 5 people here, if everyone has at least 3 friends, then I can get like a giant cycle going. So let me see here. This guy is friends with these 3. This guy's friends with these 3. There we go. Everyone has at least 3 friends, and I can find a giant cycle here. And this is like graph theory. That's the most boring introduction ever, but yeah, that's graph theory. And then studying like how this stuff works is amazing. All right, let's see if we have any follow-up questions. Yes, we do. Where is graph theory used? Can it be used in the stock market? So, oh, I was just doing everything. I was just doing everything on the screen. So, you guys are just like, what is he talking about? Yeah, it would help if I had this thing over here on my right. So, yeah, what is graph theory? Here we go. Here we have a graph. Here's what I've been talking about. There's Kyle, John, Daniel, Matt, and Jared, and they're all friends. And you can find like a cycle going on. Let me tell you how it's not applicable in the stock market. Yeah, it's not applicable in the stock market at all. It's really only applicable with communication stuff. So, for example, your brain has a bunch of neurons, and certain neurons are connected to other certain. For example, if I have it, and this is like a complex network, right? The neuron system is a really complex network. But like if I have this neuron, this neuron, this neuron, this neuron, and I have this graph, these lines just represent basically which neurons connect to which neurons, if I have something like this, and I want to know how many different ways can I get from this neuron to that neuron. That's a graph theory question. So, for example, I can go this way, and this way, or I can go this way, this way, this way, this way, this way, this way, this way. There's a lot of different options, right? There's a lot of different ways, and that's a graph theory question. It's actually a graph theory and a combinatorics question, but combinatorics and graph theory they're the same thing. They're just the same thing. They really are. And then combinatorics is like hypergraph theory, basically. So whatever that is, right? But yeah, graph theory is useful for neurology. No, sorry. Is that the right subject? Yeah, I think so. Maybe I said it wrong. I don't know. Anything involving networks. So understanding the brain and how the neurons connect. Understanding Facebook. Understanding YouTube. Like which videos should you see when you search up Amour learning on YouTube? Well, that actually depends on who you are and what you've liked. And then I'm going to give you, YouTube just gives you a bunch of videos that are relatively close to that. And they order it in a specific way that they believe you would visit first. So you might like the top, they assume that you would like the top video first, but they're always wrong. And they somehow try to manipulate this giant network based off of how you respond. So graph theory is everywhere. But the funny thing is nobody knows anything about graph theory. Like it's such a brand new topic. This thing came out like 50 years ago. Well, that's not true. It started being popular like 50 years ago. People started like really studying this and realizing, wow, like these graph theorists, we can like hire them and have them do stuff. And all of a sudden, graph theory people were getting jobs that were higher than minimum wage, which is pretty interesting. That rarely happens. So yeah, the graph theory is pretty applicable. I would argue. Where else? Anything involving flow charts. So like for example, if I have a pipe here, like a water source, and I have a bunch of different ways that this water might flow. The question is like how much of the water would flow out here? That's a good question. That's kind of graph theory related, kind of physics related. Another question might be, here's another interesting application. If you have a graph, you draw me a graph, for example, and you can actually do this, and I recommend it, by the way, if you're listening, again, free tutoring every Thursday and Sunday at 9 p.m. Eastern Time. Ask your questions in the live chat right now, and I'll get to them. But here's a really cool application of graph theory. You guys should do this if you ever have a group of people and you're throwing a party. This is a graph theory argument about cycles. So if these are like 6 people here, I have 6 dots over here. Let me make sure everyone's actually looking at the dots, because I messed it up last time. Ooh, I have a follow-up question here. Awesome example. Brain and graph theory. Yeah, it's a thing. People study this. If you go up to neuroscientists, neurologists, yeah, they'll be doing graph theory all day. But here's an example, a fun little activity you can do with like 6 people. You can do this with as many number of people as you want. But the idea basically says that if you take your hands, oops, and you shake someone's hand, and then with the other hand, you shake someone else's hand. And so let me drop my pen. Let me show you kind of what that would look like. So maybe this is me right here. That's me. I'm going to shake this guy's hand and this guy's hand. And then this guy's going to shake my hand and this guy's hand. This guy's going to shake this guy's hand and this guy's hand. This guy has 2 arms, so he's gonna shake someone else's hand. But all of these guys' hands have been used, so he's gonna shake this guy's hand. Now this looks like a jumbled up mess, but this is actually a graph theory theorem. Basically says you can untangle this. you could untangle this and get a bunch of cycles, which are just basically circles. So for example, I can move me. I might have to, you know, jump over and through some loops here, but I can move over there. This guy can move like over here. This guy might need to move a little bit over there. And I can move these dots and lines around just a little bit, but I'm still holding on to the people that I'm holding on to. You'll just get a giant cycle. So at the end of this, you would get something that looks like this. Oops, I put my pen. At the end of the day, you would get something that looks like this. A cycle. So that's a fun activity. So you can do that. Basically, you untangle yourself. Now, it's cooler when you have like 30 people, and it still works. It doesn't matter how many people you have. It'll always work. So long as you have at least 2 people, obviously. You can't do, well, I guess you could do it with yourself. It's a fun thing about induction is that when you work with like n equals 1, it's really easy in graph theory. But yeah, the idea is this will work with any number of people. This will work with any number of people, and you'll untangle. Sometimes you get multiple cycles. That's what the theory states, but theorem states. But this is a really cool activity. So if you're at a party, just have everyone shake 2 people's hands and totally get tangled up in the middle, and then unwind each other, and that's totally possible. So you might have to jump through jump through some hoops to do it, but yeah, I've taught this in class before. It's a pretty cool theorem. Yeah, so we're gonna end right now. It's getting pretty late, so we're gonna move on to well, I'm just gonna end this this live tutoring session. But again, thank you guys so much for joining in. If you guys have any questions, you can ask them in this comment, and I'll address them in the upcoming lectures. Also, this is really important, guys. If you like this, please like this video. Put a comment, say, hey, thanks for your video. And I'm not trying to get praised or whatever. I just want you to know what that does. So if you comment or you like this video, it actually boosts my video on YouTube. And I want people to be able to know that there's this YouTube live event every Thursday and Sunday at 9 p.m. Eastern time where they can get help. And this includes K through 12 and 12 and beyond. So if someone needs help in understanding multiplication, we talked about multiplication in a conceptual manner a couple lectures ago. It was pretty cool. So we can talk about whatever, but make sure you like this video. Subscribe to my YouTube channel so that you can get access to, and then by the way, click on the bell too. I mean, start looking at this random screen. Let me change over here. There we go, that's better. Yeah, so subscribe and click on the bell so that you guys can get notifications of when these YouTube live events. You're probably gonna get spammed. I do want to warn you. I'm gonna start posting in a couple days. We're gonna start posting 3 videos a day, so just keep that in mind. I apologize about the spamming, but if you want to look at some cool things about like statistics, like what is anecdotal evidence and what is independent variables and dependent variables, and what else do we talk about? We talk about the z-test in a conceptual manner. So if you ever taken a statistics class, I personally do not like statistics, but I really spent a long time thinking about how to teach this class in a conceptual manner, and there are 92 lectures total. So take a look at that if you have some extra time. Like those videos, subscribe, comment, whatever. Just do everything. Thank you guys so much, and I'll see you guys on Sunday, 9 p.m. Eastern time if you still need help. Thank you guys.